Hello and welcome back. In this video we're going to take a look how to reverse a linked list data structure. Basically there are two main ways to reverse a linked list data structure. We can do it iteratively using a while loop and a pointer, or we can do it recursively using recursive functions. So what we all need to do to reverse a linked list iteratively using a while loop, we will start reversing over the linked list, and what we need to do, we will change the direction of these links between each node, having each node, instead of pointing to its next node, this time we will have each node point to its previous node. So the first node is going to point to its previous node, the second node is going to point to the first node, third node is going to point to the second node, this way fifth node is going to point to the fourth node. So since we don't have a previous node before the first node, let's imagine we have a null pointer here. So first the first node is going to point to null, since we don't have a previous node. Second node is going to, this is going to be broken. Second node is going to point to memory address 600, and this link is going to be broken. And third node is going to point to memory address 100 instead of pointing to memory address 900. So let's store 100 here. Same way with the rest of the linked list. To achieve that, we need to maintain three pointers: a temp pointer pointing to the current node. Basically we are using this to traverse over the linked list. Most people call it current node or CUR, but I'm gonna call it temp. Whenever I say temp, I mean the current node or the current node pointer. So this is initially going to point to head node. Then we maintain another pointer called previous node or previous pointer. Initially this is going to point to null, the previous node, and we start traversing over the linked list. Unlike the array reversal in a linked list data structure reversal, we don't want to actually swap the element at the head node with the element with the tail node. In the array reversal we saw, we maintain two pointer, one pointer pointing to the index value of the first element, let's call it left pointer, and another pointer we call it right pointer pointing to the index value of the last element. As we started traverse over the array, we swap the element at the index L with the element at index R. Then again we incremented the value of left pointer and decremented the value of R pointer. Again we swapped the element at index L with the element at index R. This way we keep doing that until we reach L equal to R or R equal to L. But this is not the case with linked list data structure. In linked list data structure, as we traverse, we only need to swap the pointers, having the current node, instead of pointing to its next node, this time we will have it to point to its previous node. So let's start traversing over the linked list using a while loop. I will traverse until I reach until I have not reached end of the linked list, while temp not equal to null. I keep traversing. As I traverse, I swap the pointers or change the direction of the pointers. So I will have temp.next, this pointer I will make it to point to its previous node instead of pointing to memory address 100. So to do that, I will say temp.next equal to previous. Initially previous pointer points to null, so this 100 will be replaced with null. But if we do that, we are going to detach this link and we will lose a reference to the rest of the element in the linked list. To prevent that, before changing the current node's pointer to point to its previous node, we gotta maintain a pointer to the rest of the linked list, or a pointer to the next node of the current node or the temp node. Okay, so we are going to define another pointer, the third pointer. Let's call it next node pointer. This is our current pointer. We will have next node to point to the next node of the current node. In this case, we'll make next pointer to point to memory address 100. Where we can get the memory address 100? We can get it from temp.next. So before doing anything, let's maintain a pointer to the rest of the linked list by saying next node equal to temp.next. This way, if we break this or detach this connection, we don't have to worry about losing a pointer or losing a reference to the rest of the elements of the linked list. So now let's set temp.next equal to previous. So previous is pointing to null. We are going to store null instead of 100 here. Then I will make previous pointer point to temp. Then I will increment temp to the next node. Let's do that. So first I will say prev equal to temp. So now temp previous comes here. Then I will say temp equal to next node. So temp comes here. Again we will check while temp not equal to null, no temp is not equal to null, temp points to memory address 100. We go inside the while loop, we increment our next node equal to next dot temp, next node equal to temp dot next is memory address 45. So next node is going to point to memory address 45. So this, let's call it NN or next node. Then we will increment update the next node's pointer. Instead of pointing to its next node, we will have it point to its previous node by saying temp.next equal to previous pointing to memory address 600. So temp.next is going to store memory address 600. This link is going to be detached. Then we will update our previous pointer, prev equal to temp. So prev is going to come here. Again we are going to increment our temp pointer, temp equal to next node. So next node points to memory address 45. So we will have temp pointer point to memory address 45. Also temp comes here. Again temp is not null. We go inside the while loop. Next node equal to temp.next. Temp.next is memory address 900. So next node comes here. Next node. And then temp dot next equal to previous. We will have it point to its previous node. Previous points to memory address 100. So temp dot next is equal to 100. This link is going to be detached, and we will have, as we maintain the address of the previous node, so we will have a reverse link between each node. So temp is pointing to this node right now. Then we will increment our previous pointer, prev equal to temp, prev come here. Then temp equal to next node, temp comes here. Again temp is not null. We will update the next node first. Next node come here. Then temp.next equal to previous. Temp.next is going to store memory address 45. This link is going to be detached, and we are going to establish a new link here reversely. Prev equal to temp, prev comes here. Temp equal to next node, temp points to the next node. Temp is again not null. Temp stores memory address 400. We go inside the while loop. Next node equal to temp temp.next. Temp.next is null. So next node is going to point to null here. Next node equal to null. Temp.next equal to previous. Instead of null, we store 900. It's going to point to this node. Prev equal to temp, so we are going to increment our previous pointer. Prev comes here, and temp equal to next node. Next node point to null. Temp is also going to point to null. So temp finally equal to null. While temp not equal to null, yes, temp equal to null, we exit out of the loop, and we are going to update our tail pointer and head pointer. So first we are going to make the tail pointer point to head pointer. So we will bring our tail here. Tail equal to previous head. Tail comes here. Out of the while loop, we say tail equal to head. Then to update head pointer, we can use the previous pointer. Right now, when we exit out of the loop, previous pointer points to the last node. In this case, this node. So using this previous pointer, we are going to update our head pointer. We'll say head equal to prev or previous pointer. So head comes here. Let's clear that. Head comes here. This way we swap the head and tail pointer, and we reverse the link between each node. This way we can reverse our linked list. Let's jump to IDE and write code for this algorithm. So what I'm going to do, I will define a function in our class public void. Let's call it reverse. It's always a good practice to check for the emptiness of the linked list. If is empty, we just want to return. We don't want to do anything, return. Else we are going to maintain 3 pointers, node previous pointer equal to null initially. And then we will have a current pointer or temp pointer, temp equal to head. Then we have another pointer, let's call it next node, to maintain a reference to the rest of the linked list, or the next node of the current node. Next node, initially this is going to point to null also. Then using a while loop, we will start traversing over the linked list while temp not equal to null. We keep traversing. As we traverse, first we are going to maintain a pointer to the next node of the temp or the current node. So next node equal to temp.next. Then we will update the temp's pointer, saying temp.next. Instead of pointing to its next node, we will have it to point to its previous node, temp.next equal to prev. Then we will bring our previous pointer pointing to the temp or the current node, prev equal to temp. Then we will make temp equal to next node. Once we reach out end of the linked list and we exited out of the loop, we are going to update our tail and head pointer. This dot tail equal to head, and this dot head equal to previous pointer. At the end, previous pointer will point to the last element or the last node of the linked list, so we can use the previous pointer to update our head pointer. I think that's it. Let's run our code. I have 10, 20, 30, 40, 50. Let's run our code. Awesome. We have 10, 20, 30, 40, 50. Let's call our reverse function, list.reverse. Our linked list is reverse. 50 becomes the new head and 10 becomes the new tail. Let's add at the end of the linked list. So I'm gonna, after reversing, let's call list.insert at end. Let's add 100 at end of the linked list, and let's call insert list.insert at beginning. Say I want to add 33 at the beginning of the linked list. 33 becomes the new head and 200 becomes the tail. This way we can reverse a linked list. Thank you guys for watching. Please don't forget to subscribe, and see you in the next video. Bye bye.